Okay, so let's look at this thing then. Number one. So the process is, if I want to get m on its own, I need to get rid of whatever else is on that side. That's the way to think about it. So m is multiplied by a. So I undo multiplying by a by dividing by a. So divide both sides by a. So you get the force divided by acceleration equals the mass. And I'd write the subject first, so mass is force over acceleration. So it's a nice easy letting, but the process is you undo it step by step. So when we look at the next one, I've got to isolate alpha, which is there. So I mean, what happened to alpha, and you remember us talking about this sort of thing, is we build it up. Well, the first thing that would have happened to alpha was it was multiplied by t, and then I would have added the 1, and then finally, because of the bracket, I would have multiplied the whole lot by r0. So if I'm going to get back to alpha again, what's the first thing to get rid of? By doing what? Right, you can multiply out the brackets. I'm going to do this two ways, Andrew. So if I multiply out the brackets, I get r equals r0. Sorry, r equals, now let's multiply out the brackets. What do I get? Right, multiply r0 by 1 to get r0 plus r0 alpha t. Okay, next step. Take r0 from both sides, so r minus r0 equals r0 alpha t. And then well, it's multiplied at the moment, isn't it? So divide by t, and also divide by r0. So I can do them both at the same time. So divide both sides by r0 and t, and we get r minus r0 over r0t equals alpha. So then I would put the subject first, so on the left, alpha equals r minus r0 over r0t. There's another thing we could do. Instead of multiplying out the brackets, if the last thing that happened to the right-hand side was multiply it by r0, what can I do? Divide by r0. So another step could have been to have said r divided by r0 equals 1 plus alpha t. Now, remember after alpha, what would you do next? Subtract 1. So r over r0 minus 1 equals alpha t. Then what? Yeah, I want to divide both sides by t. Yeah, so r over r0 minus 1 divided by t equals alpha. It does, doesn't it? And do you remember us talking about a third of x? We did this probably at the beginning of last year. A third of something is equivalent to x divided by 3. Here, instead of writing it as r over r0 minus 1 all divided by t, to make it look a bit nicer, I can call it 1 over t times r over r0 minus 1, to avoid having lots of division fractions under the same thing. So multiplying by 1 over t is the same as dividing by t. So I could write it like that. So in theory, that is the same as that. In theory, that and that are equivalent. I'm not going to go through this, but as a little extension activity, see if you can show that that is the same as that algebraically. Not now, Ethan, but as a little extension exercise. And if you do have a go at it, maybe next time you would like to just take us through it, okay? So just practice your algebra skills. We're going to be focusing a bit on these further algebra skills at the start of this year. So that's a good little warm-up exercise. Number 3. What do we mean by factorise then, Philippe?
I don't know how to explain it in words.
Okay, go on.
Like 2 open brackets A was 2AB.
Well, you're on the right lines, but I don't agree with what you're putting inside the bracket. So I'm going to take a 2 outside the bracket, Philippe, which is perfectly valid.
Oh.
To find out what's left, what have I got to times 2 by to get back to 4a?
2.
Almost.
2A.
2a. Because 2 times 2a gives 4a?
Couldn't you have, instead of that, couldn't you have 2A outside?
You could. But let's finish this. What have I got to times 2 by to get 2ab?
2,
Agree?
Was first.
Yeah. Yes. Right?
2.
That's factorised. That's right, yeah.
Yeah.
But you're right, I could also take out an A.
You know what I did wrong? I put it the other way around.
Okay. Now what have I got to times 2a by to get 4a?
2.
What have I got to times 2a by to get 2ab?
3.
Right. They're both correct. There's no right answer. They've both been factorised. We might say that this second one here is fully factorised, but it could be equally valid that you would want that. You might equally just want to take out the number 2. So factorised just means to take a common element outside a bracket. So I could also just take the A outside. If I just took the A outside, what would we be left with inside?
4.
Right, 4 plus 2b. So that's another option. I could do any 3 of those would be factorising it. All it means is removing a common element. And it can be a useful thing to do sometimes. We might well see examples where that's a useful thing to do. Is that all right? Can you see? Yeah, right. So that's what factorise means. 4, expand. Who wants to go have a go at that one?
6.
Why 6?
2 times 4.
So that's,
2 times 4 is 6. And then
sorry, again Daniel, 2 times 4 is
8.
8, yeah.
Is the first one.
Yeah, yeah.
And then 2A.
Yeah,
And 4A.
yeah. Good. That's exactly what I mean by expand out those brackets. What might you do next though, Daniel? Yeah, to get plus a squared. Yeah. So I can collect together the a's to get that. So if I put the original one underneath, then this process going from the brackets to that form is called expanding, but going from a quadratic, which is what that is, back to the bracket form is called factorising. Okay? And so, do you remember we spent a bit of time last year trying to work out what these missing numbers were in these brackets? As soon as you see 2 brackets like that, with the unknown, whatever it is, x or a in both, you know you're going to end up with a quadratic, because a times a gives you your a squared. Okay? And we'll be looking at these sorts of things again, and trying to integrate functions with this in. So, number 5. How do you differentiate? Okay, do you remember? to do that in red because that's the top one. So dy by dx, if we look at the red one first, equals, I know, I think you're mixing that up with integration. When you differentiate, that comes down in front, take one away from the power, 2ax. 2 take away 1 is 1x to the 1, I'll just write x. So the answer is exactly the same for the blue one underneath, but what's the notation to show that it's been differentiated? No. What's this one? No. No, there's no d's in it at all. This is a completely different notation if it's a function. Right. F prime we call it, but I think that's what you meant, isn't it, even? F prime x means the differential. No, it doesn't matter which one you use. I tend to use the left-hand one. I tend to use this one by default, but that's often used, and in fact in some ways it's quicker to write f prime than to write dy by dx. And you will certainly see that in text and in things that we look at, so you need to be aware of it as the other way that you can show the differential. We will come later to find things like which are called a second differential. So in that case, if I wanted to show the second differential of that, that just means d2y by dx squared is the notation. So that means I'm going to differentiate again. So the differential of 2ax would be, no, same thing, but bring the power down. Yeah, 1 times 2a is 2a. Take 1 off the power, so the x just disappears because anything to the power 0 is gone. So the x disappears, if you remember, when you differentiate. So this is where this notation comes in handy, because to show the second differential, you just put 2 primes. And so that's a bit easier to find. Sorry? Yeah, third differential, you just keep adding primes, yeah. We don't often find the third differential. The second differential is common to find. Okay. Integrate that. If to differentiate down, you take 1 off the power and then bring the power down, what do you think you do when you integrate? Correct. Add 1 to the power and divide by the new power. So what are you going to end up with? I know, what's the power of x at the moment? 1. So 4x squared divided by the new power? No, you add 1. No, you add 1 to the power. Like you took 1 off when you differentiate, you add 1 when you integrate. So add 1 to the power, divide by the new power, and then at the end? Plus c, well remembered. Yeah, plus c. Always add this constant of integration, yeah? And then, if you can simplify it, do so, because 2 goes into 4 twice, so that would become 2x squared plus c. Solve it, yeah.
So, divide 3 by both sides.
Okay.
So
To get?
x plus 5
Over, I thought you were dividing by 3.
over 3, sorry.
Yeah. I'm not happy about this. If I'm dividing both sides by 3,
That's not how I actually did it.
oh, so I thought that's what you were saying to me, Philip.
No, I did it all in sort of in 2 goes, because I put x on one side, so I had like 10 minus 5 over 3, which then will be
Yeah.
5 over 3.
So what's the first thing you do? Subtract 5, not divide by 3, subtract 5, right. Subtract 5 from both sides, then divide by 3. Just as an aside, so that would be probably the best way to do it. However, I was going to allow you to carry on, because if I do take this equation, and it's worth noting this because algebraically, so long as I do the same thing to both sides, it's not a problem. It's always correct. It's just not always helpful. So if you divide both sides by 3, so long as you divide every term by 3, that's fine. So I'd have to write x on its own, because 3 divided by 3 is gone, plus 5 over 3 equals 10 over 3. Okay? Now I would subtract 5 over 3 from both sides, so x equals 10 over 3 minus 5 over 3. What's 10 thirds minus 5 thirds? 5 thirds, same answer. Okay? So in other words, Philippe, you get the same answer both ways, just that's probably easier. Yeah. So look at this equation, and again, just like for formulae, if you're going to try and solve an equation and you want to get x on its own, it's the same process. Get rid of the thing that was done last first. So it's likely, because of BIDMAS, that if you're going to multiply x by 3 first, and then you're going to add the 5. So take the 5 away first. And that sort of idea is always used in solving equations. Okay. So there's a